Thank you everyone for joining. Very excited today. As I just shared with Kathy and Scott, I got hold of the book yesterday and meeting the authors today and have a talk. The title of the book is Liquid: How CEOs and CTOs Unlock Flow and Momentum in Complex Systems. Something I've picked up from the book already is that we grow complex systems and don't build them. And if I'm making a mistake, then Kathy and Scott will correct me. About the speakers, very briefly, Kathy is a CTO advisor, executive coach, and board director with 30 plus years of experience. She's also the co-creator of the CTO Levels framework, which when you read the book, you'll understand how that's relevant. Scott is a technology leader with deep experience building and leading high performance engineering teams. And with that, the mic is yours, guys.
Great. Well, we're happy to be here and talk about Liquid. So I'm glad you were able to pick up Liquid and already start to read it. So that's great. And you are correct in that you caught that we grow systems, we don't build systems. Complexity is an interesting thing. Uh, we talk a lot about the definition of complexity. And so why don't we start there, Scott? How do you feel about that? Like starting with the definition of complexity, in that complexity there's a lot that's unknown in a complex system versus something just being complicated but known, right? So Scott, what
Yes,
thoughts there?
God, you just set me up perfectly, Kathy. Um, the thing about complex systems is that we can't model them, right? If you could model a complex system, then you could make predictions about it. There are simple systems that we deal with every day that we can model, right? For example, you can make a model of like your engines, your car engine's performance, and then you can monitor a few metrics and predict what your car's performance characteristics will be. You cannot do that for a human being, though. You can't do it because they're too complex. You can't model a human being down to their cells and atoms. Can't be done. So, how do you make predictions when you can't model the system, right? That's the fundamental problem of dealing with complex adaptive systems, is that they react to their environment in unpredictable ways. They are very sensitive to initial conditions. Something small could change in the conditions and then have a very large effect on your organization. I can't tell you how many times I have found some small little thing in an organization that was causing a problem, right? It can be as small as the format of a requirements artifact. That, like, one little thing, one little piece of information wasn't included, and it destroys the performance of the entire team. So you do not model, you don't make predictions about complex adaptive systems about modeling them. You monitor them at their borders. You monitor them from the outside. You watch their behavior, you diagnose them, and then you let that system correct itself. You put in the minimum input to get the system to rebalance itself, and then the system does the work. If the system isn't doing the work, if the team isn't rebalancing itself and reacting to changes in the world, then there's something wrong with the balance of the team and how it's set up, right? So, as a CTO or a leader of any kind, your job is to make the minimum number of inputs into that complex adaptive system as you can and let the system do the vast majority of the work. Do you think I covered that, Kathy?
Yeah, I think you did a great job. So really understanding how a system operates and understanding the boundaries that we have to influence the boundaries over time. And as Scott said, minimum amount of tweak to get that boundary to behave differently. And so this is really where Liquid comes in. Let's anchor for a moment on what we mean by a complex adaptive system in the workplace. We already said that a person is a complex adaptive system. So if your company has 100 people, you have 100 individual complex adaptive systems working all with boundaries about how they operate. And of course, all those boundaries are different. Okay. And then you put those people into teams. And so now that's let's say there's 8 people on a team. You have 8 subsystems that are part of now a bigger system, which is the team. And what are the boundaries of the team? And then the teams come together and they have boundaries as well. So you have larger systems, which are teams of teams, which are parts of your organization, let's say like engineering or marketing or finance, right? So they have boundaries as well. And then, of course, your company as a whole has a boundary about how you interact with your customers. And then, well, blowing our mind is our industry has boundaries as well, because our industries are a system. So when you think about a company as being systems of systems of systems, all of which you can only influence or tweak them to change. You can't actually build them a specific way. It gets a little daunting. And so, how do you handle that situation where systems of systems or systems are all interacting and you cannot actually predict any of them about how they're going to perform? So, what do you do, Scott? What do you do in that moment when you have systems of systems of systems, and yet you need to deliver something on time? How do you
Well,
reconcile those?
well, well, to answer that question, we have to get into the title of the book a little bit. Liquid. Why is our book called Liquid? Um, I would like everyone to imagine an ice cube for a moment, right? Um, and the thing about an ice cube is it's a crystal. So the atoms in an ice cube, they're regular. So if you know the position of one molecule in an ice cube, you can predict the position of all the other ones, right? There's going to be one to the right, there's going to be the left, there's going to be above, there's going to be one below. And it is very easy to predict the configuration of an ice cube. Very easy to predict. But the price of your ability to predict is that an ice cube can't adapt. If you take a big block of ice and you drop it into a glass, it's going to retain its shape. It is not going to conform to the shape of the container, right? Now, in order to get that ice cube to conform to the shape of the container, what do you got to do? You got to heat it up a little bit, right? And then it will change phases into the liquid state. Now let's talk about predictability. So if I have a water molecule, not an ice molecule, I can say a little bit about where the next water molecule is going to be, but I can't say a lot. I could be like, hey, maybe there are on average going to be 10 water molecules next to some water molecule that I pick out of that glass of water. But I won't be able to say much about it because they're sliding and moving around each other at all times, right? And that's the characteristic of a liquid, is that you can say a little bit about what's going on inside the liquid, but you can't say a lot about it, right? Um, and so let's talk about steam. Steam is much more extreme than water. It doesn't conform to a container. It just goes wherever it wants to, right? And if I have the position of a water molecule in a cloud of steam, I can say almost nothing about nearby water molecules. So you can see, as you as the as water becomes more and more flexible and can adapt to more and more circumstances, you know less and less about what's going on inside the water. Does that make sense to everyone? There is a
Definitely.
corresponding drop in the information that you have about what's going on inside the water, the more flexible it gets, right? And so when you're running a software team or a entire department or 4 divisions in a very large technology company, you're going to know less and less about what's going on in your departments and on your teams, and so they need to adapt on their own. The hallmark of building a good technology department is when conditions change, like maybe you're trying to attack a new customer type. You need to, you need the team to build something innovative that has never been built before. The team has to be able to do that on its own without your intervention. If it can't do that on its own without your intervention, then you will not succeed, because it's impossible for you to like go in and like tell every single person what to do. So as your teams get more flexible, they will become more unpredictable, right? And all you can look at is it conforming? Like, you don't care about the position of every molecule in a glass of water. You only care that it conforms to the shape of the glass. And so is how you that's how you handle and manage a team that you can't like really know exactly what's going on in it. Like, you got to see, is it conforming to the pressures that are being put on the organization and the company? Is it fitting into the glass that we're pouring it into? And if not, you have to see why it's become rigid. Why is it frozen? Why is it like ice? Why isn't it adapting? And you change some external conditions, and then that will cause the team to reorganize itself and conform, right? But if you go too far and you let it become highly irregular, then it'll become like steam and you won't have any control over it at all. So we call that, I say we, um, the Santa Fe Institute, which has done most of the fundamental research on complex adaptive systems, they call that the edge of chaos. You have to keep your teams right at the edge of chaos, right? Not freezing into a shape that's rigid, not turning into steam and just evaporating where you don't have a team anymore, but in that in between state where it can adapt without evaporating. And that is the challenge of a CTO. I hope that sheds some light on the situation and how
Yeah.
you manage complex adaptive systems.
So what does it mean for, let's examine a little of what does it mean for your team to be boiling or freezing? Scott talked about the edge of chaos, right?
Mm-hmm.
So I think about that. I've got my cup here, right? It's got liquid in it, right? The liquid moves around in predictable ways. It's conforms to the cup. It's not spurting out anywhere. That's the boundary of my team, right? It's well known. You can predict the color, you can predict the shape, but yet in the middle, it can move pretty fluidly, you know? It can be adaptable, it can be malleable. The team can achieve what it needs to achieve inside the boundary. But as a CEO, I can predict what that team is going to offer because they're liquid. They can operate within themselves, but from the outside, they are predictable, right? So that's a concept of a liquid team. So just reinforcing
Mm-hmm.
what Scott talked about. But what causes a team to be steam or boiling versus rigid? Okay, let's talk actual scenarios, right? The team is working, but some other team, let's say the product team, forgot to tell the engineering team, which is my cup, a particular massive requirement, right? And so the engineering team thinks they're at delivery or close to delivery, and product comes in and says, "Oh wait, we forgot a requirement," right? So now one team has to inject another thing into injected into another complex adaptive system, which is the engineering team. And then you have your CEO and your head of sales, which have already made commitments based on the original delivery date, but now the scope has changed. How many people have ever had this scenario? I think everyone will raise their hand, right? Because it's so common. Because the software itself that we build is a complex adaptive system. Okay. So now we're in crisis in which the predictability of the system has, let's say, gone out of whack, right? So there's two ways we can adapt to this. We can notice that we're starting to boil, right? Because a new thing is being injected in. So we're starting to boil, chaos is starting to happen. We have to adapt, right? So that chaos is starting. Once we recognize that, we can replan, right? And that replanning might be talking to the customers, telling them it's going to be another couple weeks. It might be holding off on some marketing, right? So again, we can nudge, or as you said earlier, you're growing, right? You're
Mhm.
influencing the system to come back to liquid because it's starting to boil because of the new requirement. Unfortunately, what often happens in this situation, your CEO, your sales team, they're highly stressed. They've already made commitments. And what do they do? They immediately go, you are going to deliver what you said you're going to deliver when you said you're going to deliver it. And I want to know X, Y, Z, A, B, C of what you're going to do. Okay. What is that doing? That is actually moving the team fully over into frozen. The team is now going to have a checklist of everything they need to do. Everyone's got to work extra hours. Again, our reaction to the chaos is to move directly to freezing rather than moving back to flow, which is liquid, right?
Mhm.
And so oftentimes in complex systems, we'll overreact and we'll move from one extreme to the other extreme. And we'll see this often in companies is they'll bounce from frozen to boiling to frozen and boiling. And the transition through liquid, they don't even notice it because they're moving so fast. But liquid is where we want them to be. We want them to be in flow. We want them to be adaptable and malleable inside the cup, but have the boundaries be really clear. Does that make sense, Scott? Did I make a good analogy? Did I miss anything about the
Yo,
team?
you that was wonderful, Kathy. And I would like to give another example of how you have to intervene and correct problems because there's been a change in the state of your team, right? So one thing about water and it's sort of any complex system like that is that when changes typically don't happen gradually, they happen suddenly. Like if you're heating up a pan of water, it will just suddenly transition to boiling, right? Like 1 second, you've been sitting there watching the pan for, like 10 minutes. The water looks basically the same. And then in a span of like 2 or 3 seconds, it'll turn into a rolling boil, right? And freezing is the same way. Water doesn't gradually freeze. If you could put a camera in your refrigerator, you would see that the water would get colder and colder and colder, and then suddenly it would crystallize like pretty rapidly, right? So those are phase changes. Phase changes are typically exponential occurrences, and you will think that you have a great running team, a liquid team, and suddenly it will change phase. So I want to give you an example of something that you've probably experienced that will cause a sudden phase change in your team, right? So let's say that you have just delivered an MVP, the customers are really liking it, and you get this break period. There's kind of this like whenever I don't know if you guys have ever experienced this, but after like a major shipping event, like you have a big release or an MVP or something like that, the team kind of just rests a little bit because they've been going hard, right? And then also the product organization is usually kind of like depleted of requirements. They have some requirements that are just sort of lower priority that they're going to give the team now because they've already met the larger goal. When when requirements sort of trickle into a team and the team is like not under pressure, they get into a situation where they kind of like don't know what to do during the day. Like they're like, "Oh, is this the most important thing? Is that the most important thing?" And when people get into a situation where they're uncertain like that, they'll start following the rules, right? Like if you've told them that you need to have 5 check-ins a day, and we're going to be looking at that, even if they don't have anything meaningful to do, they'll do 5 check-ins a day. They will rigidly follow the rules. So when you have an event where you take pressure off of a team like that, they start rigidly following the rules, and they can sometimes suddenly transition to not being able to do anything at all. And then you'll be like, why did my team that just shipped this amazing product, suddenly I can't get them to fix 5 bugs? It's because your team has frozen. It's because they've suddenly transitioned into a different state. And when that happens, you have to intervene to change it. But these sudden, rapid changes of team behavior that seem to come out of nowhere, that's the action of a complex adaptive system.
So we see this a lot with CTOs. So I coach a lot of CTOs. Scott talks to a lot of fractional and CTOs, plus lives in that chaotic early stage company where a lot of this chaos happens. And we're constantly having dialogue with CTOs that said, I have no idea, and all of a sudden everything is broken. Or I just feel so reactive. I just don't know how to get out of this, right? And it sneaks up on us. We actually allow a lot of behavior that is, let's say, simmering, starting to simmer, boil, um, to happen because we can't see it. There's too much going on. We're in too many meetings. And so this simmering boil, you can actually do this. Put a pot of water on the stove and heat it up, and you'll see you can't see the water change until all of a sudden it's simmering and then it's boiling. Like it's really fast, like Scott says. And that's exactly what's happening in our companies. Our companies are slowly starting to simmer, or as Scott said, they're all of a sudden starting to freeze. And we aren't recognizing that as leaders. And unfortunately, that's the moment in which we can best influence the system to come back to liquid or flow, is in those moments when we can't actually detect that it's happening. So what do we do about that as leaders? That's really interesting because we can't see it, but it's happening. And 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 we want to come back to flow in the moment that it's easiest to re-nudge us back. And so what really happens is you have to start to recognize the patterns that are underlying this that you actually can't see, right? It's the subtle little conversations where someone says, "Ooh, this is like feeling really hard," or "I'm a little behind," right? It's the things that we kind of let slide today that actually we need to start to pay attention to. It's the small indicators and it's the consistent tweaking of ourselves back to liquid, which are gonna keep us in the most effective flow in order to be able to grow, right? And so, like Scott, what are some, like, you're deep in like early stage company right now where constantly probably feeling like you're in chaos. How do you start to see those tiny indicators happening in your situation?
Well, um, well, I'll give you an example, just ripped straight from like yesterday. Um, we have made a lot of progress towards the MVP, right? And this is a situation, of course, that I know that you guys have that every one of you has been in, that you don't have enough budget or people to get the MVP done. Yet you have to get it done somehow anyway. So you start making compromises, right? So I like to avoid big bang integration as much as I can, which is like everybody sort of builds things separately, and then at the end you like try to push them together. Um, so we went from a team that was had like a very high velocity to a team that had almost no velocity when we came to the integration phase, right?
Mm.
And that can be predicted. I planned for it, right? And then when I saw the chaos happening, we started mobbing, right? We all got on the same call. We worked on one problem at a time, and people were mostly resting on that call and not like constantly working. And that synchronization mechanism of having everybody work on one integration problem at a time cooled the team down, right?
Mm.
And then my velocity went back up. So like you have to keep a close eye on things that that are coming up that are going to change the phase of your team. And you have to have a plan for how am I going to take the heat out of the team, right? Or how am I going to heat the team up if they can handle more, but they're not but they're not delivering, right? Like I'm not using the full capacity of my team. It's too cold, right? So I hope that was clear. Hey, there was a question in the chat that I
Go for it.
want to talk about, right?
Go for it. You want to repeat the
Um,
question?
yes,
And
I do. So Randall's asks, don't want to distract, so feel free to address later. How do I reconcile with the CinFin framework's definition of complex versus complicated versus chaotic versus clear?
By the way,
I can't remember. What's
sorry to
that?
interrupt. By the way, sorry to interrupt. We had said about 20 minutes of talk and 20 minutes of Q&A. So perhaps after this, we can just open the floor and you guys can take questions
Yeah.
too.
that's
Well,
great.
I have a hard stop at 40 because I
Yeah,
at
yeah. So
11:40 because I
don't
am
worry.
shipping an
I
MVP.
end all calls on
Right.
time.
Right. So this is, I guess, the first question, right?
Okay. Okay.
So I can't remember the gentleman's name. He's a British gentleman who who created this framework. And his name escapes me at the moment. But we're very familiar with CinFin, right? And so I think that the difference between the way that we think about, well, first of all, both CinFin and our framework and way of thinking about it is based on complex adaptive systems, right? So he recognizes that management is all about shepherding a complex adaptive system. We realize that too, but there are some pretty clear differences between how he approaches the problem and how we approach the problem. Um, so he kind of has, if you ever seen his diagram, and if you click, actually, if anyone clicks on the link that that Randall has posted into the chat, you're going to see a figure, right? And what you see in that figure is very hard boundaries between these states that he outlines, right? So there's this sort of gooey middle part, and then you have, and those sort of taper out into like clear boundaries. I do not agree with that. I think those boundaries have a thickness. So if I were gonna draw this picture, um, instead of the person who invented the framework, I would not show those as lines. Those always have a thickness, right? And that thickness there is the period where you're actually transitioning, right? So like if you're going from like is like from like clear to complicated, there's not like a razor sharp line like that. There's actually a ditch or more like a tube. And that's very important because that is the region where you detect that there's a phase transition going on, right? And I feel that he neglects that in his framework, but we do not. So, any questions about that?
The one thing I think about is as humans, we like to simplify very complex things that we can't grasp um, into very discrete buckets, right? And I think that's what
Mhm.
I hear you saying is like, oh, that's a complicated systems is a very like discrete thing for us to say. But the truth
Mhm.
is we can be both boiling and freezing and liquid all at the same time in different aspects of who we are and or who our team is or whatever. And so we can be both frozen and boiling at the same time. And it's in different aspects. And so some things we might be thawing off and some things we might be cooling down. And how do we keep all of that in sync is pretty interesting. And so I think as humans, we like to simplify things. I love this framework. I love our, our framework. It's all really just different ways of looking at the same problem, the
Yeah,
same
that was
challenge.
oh, I'm sorry to interrupt you, Kathy. That I'm sorry. I'm so glad that you said that because that is also that's something that I've neglected to mention. Because he does look at this as like as one thing, like everything's chaotic or everything is simple. But if you read Liquid, you'll see that we distinguish between different types of complexity, right? So the technical complexity of your software could be boiling, but your market complexity might be frozen, right? And he doesn't break those out separately. So, I mean, I think that's a deficiency of their framework. I'm sure they could find deficiencies in ours.
Absolutely.
Mhm.
So, well, thank you for that. Just to kind
Mhm.
of clarify, it was less about a comparison. I think Liquid talks more about motion, which is a really interesting kind of concept. I wasn't really so anchoring on the diagram, more the definitions of complex and complicated, and the way that you describe them, the way that he describes them are different. And that
Mhm.
was one of the things I wanted to try to wrap my arms around because you talked about modeling. I think about complex as like an F Formula One race car engine. It is in millions of tiny little pieces all working in an incredibly complex system, but you can model every single aspect of it. Complicated is like the human body. Like they're even just a little part of the human body has got so many different dynamic aspects that you can't really effectively model it. You can model aspects of it, but you can't model the full system behavior. So I was trying to reconcile that kind of my understanding of
Yes.
that compared to how you were describing it earlier.
Very insightful, Randall. Very insightful. Very insightful, my friend. And I would like to talk about that because there is, so one of the people so like if you trace sort of like the lineage of all of these ideas about complex adaptive systems, you will eventually wind up at the Santa Fe Institute, because the Santa Fe Institute is the key think tank that is leading the charge on these ideas. And one of the founders of that of the Santa Fe Institute is Murray Gell-Mann, who is the person who predicted the existence of quarks and gave them the name quarks. And one of my favorite quotes from Murray Gell-Mann is, imagine how hard physics would be if electrons could think. If electrons could think and make decisions and vary their behavior, you could not do physics, right? And so I would say the difference between a Formula One engine and a software development team is that the components of a software development team can think and vary their behavior. Whereas in a Formula One engine, you would like those parts to behave consistently and predictably all the time. You built it so that it would be that way.
So it's
And that,
complicatedly complex.
yeah, so I would say, yeah, so that's the distinguish. In a complex adaptive system, the parts can think and vary their behavior, and that's what you want. That's a feature, not a bug. But there are systems that we call complex, but actually their parts are very regular. And that's why we can build them and maintain them and predict their behaviors. But that comes with the limitation that their behaviors are inflexible. Does that answer your question, Randall?
Yeah, it gets to me that tightly
Mhm.
coupled versus loosely coupled, right? I would say actually a Formula One race car is complicated, but everything is tightly coupled. Everything, the boundaries between each of the parts is very well known. What's complex about it is what happens when the person gets behind the wheel and drives
Mhm.
it, right? Because now that person can think, and so the person, the driver, actually makes it a complex system. Um,
Mhm. Yep. Was that helpful, Randall? Did that answer your question?
Um, a little bit. I'm still trying to wrap my arms around the nuances there, but we can move on. That's more my brain has
Well,
my
It's
well,
brain's
hey,
complex.
Well, hey,
I,
hey, Randall. Before we move on, I know that you're hungry for very specific answers here, and unfortunately you're going to have to wait for our next book, which is our working title there is Creation Engines. In that book, we're going to articulate, so you can't model a complex adaptive system to predict its behavior, but you can characterize how much complexity is in it. You can give it a degree of complexity so that you can compare the complexity of two systems. It's kind of like how you could not really model fluids, right? You can't really model fluids and predict their behavior very accurately, but you can come up with a number like temperature that will help you put some limits around its future behavior, right?
Mm,
And we are going to have those metrics. We're going to teach you how to measure the quantity of complexity in a complex adaptive system without actually modeling it and directly predicting its behavior in a deterministic way. And I think that might satisfy you.
I'll jump in. I always have questions.
Go for it.
Can you talk about John Gall and his definition of systems? And
This is funny.
it's one of my favorite quotes, but
Mhm.
your take on it. If you need it, I can pull it up.
Yeah, for the benefit of the group, if you have it handy, if you could pull it up so that we could see it, we'll be happy to talk about it.
Sure, hang on. He wrote a book in the 70s about system design. Hang on. I want to make sure I get the language correct. There we go. A complex system that works is invariably found to have evolved from a simple system that worked. The inverse proposition also appears to be true. A complex system designed from scratch never works and cannot be made to work. You have to start over, beginning with a working simple system.
Mm.
Yes, that is Gall's law. And Gall's law is certainly a foundation of our thinking. Here's some applications of Gall's law to being a CTO are you should never greenlight a project that is going to take big leaps in complexity. Like we kind of know this now, right? That's the whole idea behind Agile. But when I was a young whippersnapper and didn't have quite so many gray hairs, we would try to write a big functional requirements document, build the whole system at once, and then put it in front of customers. And the reason why big design up front doesn't work is Gall's law. Agile software development, where you're making frequent shipments and getting frequent feedback, is a application of Gall's law to solve that problem, right? Because what happens there with Agile is you're actually building simple. You start with a very simple version of your software and you slowly make it more complex, right? And that's what John Gall was talking about. Like you will not find complex systems that spring to life all of a sudden, like Athena from Zeus's head. Like they all, like, complexity grows it grows in a like sometimes almost linearly or sometimes logarithmically, but never just springs into existence all at once. And if you try it, it will never work. And John Gall's right about that.
The other place I see this happening all the time, because I work with mid-sized companies, is as a startup, they just ignored a bunch of the simple systems that they needed to build when they were small. And so they live in chaos almost entirely. And then all of a sudden they get to about 10 million, 8 million, and they haven't built the simple systems in which the complex system, the bigger company, can be built on. And so they have this rocky foundation and they're so far behind because none of those simple systems are there on which they can build upon. And so most mid-sized companies go through this, have to go through a radical transformation to rebuild themselves from scratch because they didn't just build the simple systems, the effective lean systems at the beginning. So. And I know we're over, so great conversation. Thank you for having Scott and I. Appreciate it.
Okay.
We're both on LinkedIn. Feel free to reach out to us. Happy to answer and continue the conversation.